Hello everyone. Today I am going to explain the theory and steps to have your principal components on your data. So, so this I planned to produce 3 videos based on theory and steps, then code execution in R, then data analysis. So in this video, I am going to explain the theory and steps to have your principal components. So let's start. Okay, the theory. So for principal component analysis, you can either use the singular value decomposition or you can use spectral decomposition. So in this video, I focused on singular value decomposition, that is in a short form SVD. So what actually singular value decomposition I denoted is as M, and what is this? It's a factorization of a real or complex matrix. Okay, so and this is a non-square matrix, M by N matrix. On the other hand, another two matrices like U and V, these two matrices are square matrices. Okay, so U matrix is M by M matrix, and V matrix, you can see B matrix is N by N matrix. And uh, in singular value decomposition theory, it has been used the transpose of V matrix. And in the middle, this is actually a rectangular diagonal matrix. You can say orthogonal matrix. So this is in the middle, sigma. So if you factorize if you factorize these three matrices, then you will have M. That means a matrix. That is your singular value decomposition. Okay. So let starts with the steps. So first, you have to choose a good data set actually. In programming, it's very important to choose a good data set. So choose your data set or data matrix, then go for further. Like first, what you have to do? You have to calculate two things first. First thing is average mean of rows of your data set or data matrix. That is actually its common arithmetic mean. Okay. The next one is average matrices on your means. Okay, so you have to compute this one as well, and you can compute this with the multiplication of your average mean and vector of one vector. Okay, so next step is to subtract your mean. So what you can do to have your new data set, you have to subtract your average mean from the average matrix. Okay. In the next step, you have to find covariance matrix of your newly generated data or data matrix. For me, I denoted as D, so you have to compute the covariance matrix. It's also nothing but correlation matrix of SDB. Okay, so covariance matrix of rows of D matrix. Okay, you have to generate this. And how you can generate this? You can generate the transpose of your D matrix and multiply with the D matrix. Okay, so and this will be your covariance matrix, and it is a singular value matrix as well. Okay, next step, you have to compute the eigenvector, okay, with the highest eigenvalues of your covariance matrix. And then you have to multiply, or you have to apply the singular value matrix, its covariance matrix with on your eigenvector. Then you will have your eigenvector return and along with the eigenvalues, and based on the eigenvalues you can select your eigenvector, and this eigenvector is will be used to compute the principal component. Okay, so the next step is to project your principal component. So I denoted principal component with the P, and you will have your principal component with the multiplication of D matrix and your vector matrix. And here is the application of your singular value decomposition. Okay, this is factorization. Actually, the out P as the output of factorization of D and V. Okay, so here you can see this is again returns to the singular value decomposition theory. So for R, in R, you can use either singular value decomposition like this way, and you can use the command like prcom function to calculate in R programming. Okay, that actually this function is a built-in function that used singular value decomposition. Thank you very much for watching this video. Thank you.